Today what we'll do is look at what are called user-defined exceptions, and then very big quiz of 25 questions. We'll do that after that. So we will start with creating a user-defined exception. First we'll create it as a checked exception, first we'll create it as a runtime exception, then we'll create it as a checked exception. You can see both. But before that, why do we need user-defined exceptions when Java gives so many exceptions? In the last 2 sessions, we have seen array index out of bounds, we have seen class cast exception, number format exception, file not found exception. We have seen many. Given all these huge number of exceptions which Java already provides, why do we need some more exceptions? Why do we need user-defined exceptions in the first place? Well, the exceptions which Java has created are for its own functionality, like file handling, like array handling, like later you will see threads. These are exceptions which have been created for those specific purposes. If you have a problem with a list, there is an exception. If you have a problem with a thread not completing, there is an exception. For something to do with I/O, something to do with databases, there are exceptions. These are exceptions which Java has created for their own utilization. Now, when you are creating your own classes, you will need your own exceptions for your specific problems. So today we'll take one example and we'll write an exception for that. And I am taking that problem from inventory management. You know what is inventory management, right? Inventory management means basically checking whether you have enough material for a particular product, giving out material, taking in material. Inventory is also called warehouse. In every factory, you will see there is a warehouse. In a warehouse, you keep materials on shelves. Then there is a warehouse manager. That all type of applications are called inventory management application. Of course, we are not developing a inventory management application in one session. We are just going to create a small class called material, which is the single most important class in any inventory management, the ability to keep material. Okay. Now, what is this material? Well, every material has a name. Every material has some, let's say, price. That's not important to our problem. But every material, a factory keeps an important item for every material, which is called QOH. What does QOH stand for? Quantity on hand. That means how much of this material I have in the factory. That is called QOH, quantity on hand, for every material. So we'll have this important field called QOH. And then as material gets issued to the shop floor, we have a withdrawal of material. That is, the material gets issued. It's called issuing material. If you understand factory systems, this is how they work. They issue material from the inventory to the shop floor where it gets manufactured. So issue is there. And then similarly, receipt or purchase of material is there. There, where the material comes from the godown into the factory, that is called receipt of material, incoming material. So we'll have these 2 transactions happening on material. One is called receiving the material, the other is called issuing the material. And there is one more important aspect. I'll describe it again. There is one more important aspect of material. At no point the material, that is quantity on hand of material, should be allowed to drop below what is called as a reorder point, meaning that is the lowest threshold of the material. If it falls below this, automatically there is an alert in the system and new material has to be ordered, because this material has to have a minimum inventory. If it is falling below that, then automatically the software system, whether you are using an SAP or an Oracle application or anything, it will automatically issue a purchase order saying get more material because I am going below that point. Okay? So we are going to design a material class, and then we are going to have an exception on it when the quantity goes below, which is an exception saying reorder point has been breached. It's called breach of the reorder point. Breaching means crossing. You should not go below the reorder point ever, because if it goes below, that means your factory is going to starve, and starvation is bad for a factory, because then workers are just idle, machinery is idle, and the owner will lose money. So he will never allow that to happen. And at the same time, in any factory, if you have excess raw material, that is also a problem, because you have paid for that material and you are not using it. So it's accruing interest. You have paid for it, you have given money, and you are not using that material. So you don't want too much of inventory, right? So any design of a software system for a factory has to ensure not too much inventory, not too less inventory. It's called, in Japan, they call it Kanban, just in time. So you should, this is how most of our Walmarts and factories work, or even one of the biggest thing, you will see it all around, the success story of DMart, you know DMart, no? Is that they are the best people to manage this. See, a shop succeeds when its inventory is very low, but it is not so low that it cannot fulfill the customer. So that is a very smart management, which every department store, DMart does it the best, they say. That, and it's all a software challenge, how well you manage your forecast and how well you manage in such a way that expensive material are not stored with you unnecessarily, accruing interest. And at the same time, your customer should not find an empty shelf. If he finds an empty shelf, he will go to some other shop and never return. Many of those will never return, so you can't risk that. So it's a very important thing about material management. We are going to do some of it here. So, and then we are going to use exception management to do that. It's just an application, an example. So let's design a small class, and then we'll realize how to create exceptions on it. Why should we create exceptions on it? Okay? This is an example of user-defined exceptions. Now these exceptions on material you will not find in Java. Java is for standard exceptions like files, arrays, lists, and threads and all that. It cannot handle material. This is a user domain, correct? For example, tomorrow you are having a bank and you are creating software for a bank and you run short of money in your account. That is an exception. Now that is not an exception which Java will envisage. That is an exception which comes under user-defined exceptions. So all those exceptions, you have to create them, and it's very important that you create them, because without which your software won't work. And that's why we learn exception management in so much detail. So now we are creating class material. Let's create a very simple class, and then let's see how exceptions happen, or how exceptions are programmed around this material. So we will start. So we'll say string mname, that is the name of the material. Okay. Then we'll have an int QOH, which stands for quantity on hand. How much of this material do I have? Are you with me? Do you understand QOH? Quantity on hand, simple, nothing more elaborate, nothing less elaborate. And then you will have what is called as int reorder point. It's called RPT, reorder point, which means it cannot fall below reorder point. If it falls below reorder point, that is an exception. And what should be the reaction to that exception? Reaction to that exception should be to create a PO, PO means purchase order, and give it to the vendor and say, get me more, because I'm running short of this. The way you manage your reorder point is the whole game. This is how you make millions or lose millions, right? If you don't manage inventory well, what happened to Big Bazaar? Poor management of inventory, or over capacity management, or under. So many shops or chains have closed because they cannot manage inventory. In all of retail, you know the only challenge? How well you manage inventory. And that is where software plays such a major role. That's where your packages like SAP, all these packages become so predominant. Okay, so string mname, int QOH, int RPT. Now we'll write a constructor which will initialize this data. So let's create a constructor which takes 3 parameters, string m, int q and int r, and it does nothing great, it just initializes it. So we'll say mname is equal to m, QOH is equal to Q, and RPT is equal to R. Okay. So we created material. Now we are going to write 2 transactions or 2 methods on material. One is called issuing the material, that is giving the material. Other is receiving the material. What does issue do? Reduce the quantity on hand. What does receipt do? Increase the quantity on hand. Very simple. Okay. So we are going to write those 2 methods. Issue material void. It takes a parameter int, let's say issued material IM, and we will decrement our quantity on hand by that. QOH is equal to QOH minus IM, issued material. And now if this new QOH, okay, if this new QOH is below the reorder point, you understand what's happening? Material is being issued, we are reducing our quantity on hand because that much material is going out, it's getting issued either to the shop floor or to the customer, whatever. Okay, once it is issued, my quantity on hand has dropped by that amount, and now in that same method, if QOH is less than RPT, my reorder point, that means I am now dangerously low on this material. So if QOH is less than RPT, throw. Now I am going to create an exception. Throw. How do you create your own exception? You do the throw, not throws. Throw some name of the exception, new. We will call it material exception or call it shortage exception, call it material. Okay. No, don't call it material, call it shortage. It's a shortage exception, and it takes as a parameter, okay, it should take as a parameter the current QOH. Okay. So I have created this, I don't have right now, correct? I don't have this exception. No, yes. This is not a Java exception. This ought to be our own exception which we need to create. We have not done it yet. Okay. So we are having QOH is equal to QOH minus IM. If QOH is less than RPT, that is the quantity on hand has dropped below reorder point, then I am throwing a exception. The name of that exception is shortage exception. I am having a shortage of this, and this is my new material that I have, which is the remaining material. Okay. So is this clear? No, yes, just this part. Okay. Now, okay, else, no, else we don't do anything. Okay. So we leave it. Okay. Now there is similarly receipt of material. I receive material from the godown or from the factory or from wherever. So receive material, int quantity, int q. Okay, that increases my quantity on hand. It goes up. So QOH plus Q. That's it. Very simple class, because our objective is not to do inventory management but to learn exceptions. Is this class clear? Class material. 3 variables, name of the material, quantity on hand, reorder point. Okay. Then the constructor, then a method for issuing the material. IM is the material which needs to be issued. QOH is equal to QOH minus IM. If QOH is less than RPT, then we have a shortage exception, and receiving material will increase the quantity on hand. Okay. So shall we start now using this class? Then we'll write the exception. Okay. First let's write the main, and then let's write the exception. Okay. So we'll create a material object M1 with the parameters. Okay. New material. The parameters are 3. Name of the material, let's say bread. Okay. And the quantity on hand initially will be 0, and let's say the reorder point is 100. So as of now we can't issue any material, it will go into exception. Okay. So currently the quantity on hand is 0. Okay. Now let's do some transactions on it. So we'll say M1 dot receive material. Okay. Let's receive 200 pieces of it. Okay. I received 200 pieces. Now my quantity on hand is 200 because I received 200 pieces. Now I'll issue some out. So I'll issue, let's say, 75 out. Okay. Then I'll put a system.out.println. First issue over. First issue succeeded. First issue succeeded. So first issue succeeded. Then again I try to issue. M1 issue material. Again 75, and I will say system.out.println. Second issue succeeded. Okay. So this is my program, very simple program. I receive material 200. Sorry, first I create a material bread with the current quantity on hand 0 and with with a reorder point of 100. Now I issue 75. Sorry, I receive material 200. I issue 75. So right now my quantity on hand will become 125. So 125 is not breaching the reorder point, so no exception at that point. But with the second issue, the reorder point will be breached. It will go below, it will become like 50, which is below 100. So the shortage exception will come and I have to handle it. What I do in response to shortage exception is our job. We can order, we can do whatever, but we will come to that. Okay. Is this part of code clear first? Right now this code won't compile. Why won't it compile? Because there is no exception which is called shortage exception. Correct? We have never created an exception like that. So now we have a choice. Okay? Is everyone getting it? No. So now we have a choice whether we want the shortage exception to be a checked exception or to be a runtime exception, unchecked exception. It's a user defined exception, so it's up to us to decide what do we want it as. We can have either runtime. If we make it a runtime exception, code will compile, but at runtime you will face the music in case there is shortage. If you make it a checked exception, unless you handle the exception, it won't compile, correct, or report the exception. So first let's make it a runtime exception and then let's make it a checked exception. That's a matter of just small change. So we are going to start with a runtime exception. So how do we create an exception, our own exception? Now let's go down. Yeah, we can create it anywhere but a separate class. So now it's very important to understand how do you create any exception. Okay. So as I said, first decide whether it's a checked or an unchecked. How do you decide? Based on what inheritance you need. So if I'm making it a unchecked exception, a runtime exception, then I have to derive it from runtime exception class. Okay? So let's say class shortage exception extends runtime exception. So we are saying it extends from a runtime exception, so it's a runtime exception, it's an unchecked exception because of its class hierarchy, the way it has been created, the way it has been inherited from. So now I have class shortage exception extends runtime exception. Remember now our shortage exception takes a parameter in its constructor which is the I think the quantity on hand, right? That is a exception it takes. So when we create this exception class, we should have that constructor which takes an integer as a parameter, because that is how we are invoking the new on that shortage exception. Okay? So we are saying now we write the constructor for an exception class is just like any other Java class, nothing very glorified about it, except that it has to have generally a method called getMessage which it overrides. Okay? Anyway, we'll write that in a moment. So first just say shortage exception which will take int q as a parameter, and we will have a variable there called qh, no? Int, that is the exception variable. You can have anything you want, and we'll say qh is equal to q. That is a variable inside the exception. So class shortage exception extends runtime exception. We have int qh as a variable, and we have shortage exception int q, qh is equal to q. Okay, that's it. Now remember, most of the exception handlers on an exception, what method they call? Exception handlers. That is in the catch block. What do you do normally with an exception? What method do you call on that exception? Arey Baba, what method do we call on an exception normally? GetMessage, isn't it? Most of the time we want something about that exception. So we call, generally every exception has a getMessage method. If you don't write it here, whatever is the inherited thing will come. Okay? So now we'll write the getMessage method which returns a string. So string getMessage. This is a method we are overriding. So getMessage, it has to be written exactly like the way it is. Okay? So string getMessage, it doesn't take any parameters, and we'll say println. Here we give the good message. Okay? The quantity on hand, we give a nice message. The quantity on hand has dropped below the reorder point. Full stop. The QOH is now, the QOH is now plus that QOH which we have as a variable. I am making a big message, doesn't matter. Q or QOH? What is the variable name? Okay. So look at the way we have created this exception, and please try and understand. Just don't be blank. Think please. Some of you are just becoming not thinking. Okay. Look at the way we have created the exception. Class, look at the first line. Class shortage exception extends runtime exception. That's how you create an exception. You have to derive it from some exception class. If you derive it from runtime exception, it becomes a runtime exception. If you derive it from exception class, then it becomes a checked exception. Okay, this is an unchecked exception. So we have class shortage exception extends runtime exception. Now as usual, we have a constructor to that exception which takes some parameter q and assigns its internal variable, instance variable, QOH to q, and it has overridden the getMessage method, and that getMessage method, when it is called on in the handler, will have system.out.println the quantity on hand has dropped below the reorder point. The QOH is now so and so. This is the message. Okay. Now, since it's a runtime exception, now the exception is created. So there should not be any compilation errors because it's a runtime exception and the exception is there. And you know runtime exceptions, even if you don't report them or even if you don't catch them, you will get them. I mean, you can compile the code and if the exception comes, you will get the message. I mean, the program will bomb out, right? So, okay. Now, let's proceed and understand what happens. Okay. So, what will happen? Okay. So, let's analyze what will happen. So, we'll have M1 dot receive material 200. So, M1 starts with material 0 and a reorder point of 100. So, when on line 33 we receive the material, our QOH will go to 200. Then issue material 75. So, if you go to the code for issue material, you see there it takes an integer parameter and reduces the QOH. If the QOH falls below reorder point, then it raises an exception. So, QOH less than reorder point, it says I will create an exception called shortage exception, taking the current QOH as a parameter. Okay. Then you go down. So, at line 34, the QOH will become 125. It is not below the reorder point, so no exception. Again, so first issue succeed, that line will come. Then we have M1 issue material 75. Right now QOH of this material is 125. Now it will become 50. 50 is below the reorder point. Reorder point is 100. So what will happen? It will throw an exception. It will instantiate an exception. Now if our program is catching it, it can get that exception. If it is not catching it, the program will bomb. Bomb means come out. And our main will print some error exception caught in main by the JVM. And it will give the same message. So now, since it's a runtime exception, it's not compulsory on our part to catch the exception or to even report the exception. Code will compile and as we see, the problem will come and our program will erupt. So that will happen. So let's see it happening and then we can go forward. So let's run this program and see what really happens. Okay. So there is, now get message is cribbing. He is saying, cannot override. Okay, go back. It is saying attempting to access weaker privileges because the method was marked as public in the original exception class, or runtime exception class. It's actually inherited from exception to runtime exception. The message, the method get message is a public method. And okay, this is something which I think I talked about, but I don't mind repeating again. Now please listen, these are fundamentals of Java. The get message method in the base class, that is runtime or its base class, what is the privilege of that method or what is the visibility of that method? I have not gone through it formally because I was waiting. Package, private, public. But I will tell you that get message method is marked as public in the base class. Yes, no? Okay, it is marked as public. And now look at the way we have created get message here. Can you see that? Now, this is the derived class. This is derived from runtime exception. Think of it like this. In runtime exception itself it is public and in the derived class it is not public. It is actually called package level access. That is access within the package. So what has happened? And that is what the Java compiler is cribbing here. He's shouting, saying at a higher level you have, at a base class level, you have marked this method as public already. We didn't do it, it's like that. And in the derived class level, you are making it only package. That means you are reducing the visibility of a method in a derived class. Okay. Now this is for Java Not acceptable. Java, I told you, is a very strict language. So Java says, no, I will not allow you to do this. You cannot reduce the visibility. You cannot make it less visible in the derived class. Please remember, this is not just for exceptions, this is for anything. Whenever a derived method is overriding a base class method, if the base class method is more visible, which is the case in this instance, the base class getMessage is public. The derived class getMessage is package, which is reduced. Only visible within the package. Public means visible everywhere. That is how it is originally. And I have not put public. So what is it? It says in the base class, everybody can access it. In the derived class, you can't reduce its visibility. You can either keep the same visibility or I will allow you to make it more visible. If it was packaged there, I could have made it, if you had declared public, I wouldn't have cared. Good, you have made it more visible. But here you are doing ulta. What are you doing? Something which is more visible in the base class, you are reducing its visibility in the derived class. That I am not going to accept. No classic object-oriented language ever accepts this. They say derived classes can improve visibility or keep it as it is, but they can never reduce visibility. So now, for the getMessage method, we are actually reducing its visibility. Say, I will not allow this. It's a very important lesson to learn, that I cannot reduce visibility. Okay? So I will have to say public here. You can't increase beyond public. So if I mark public, Java compiler will feel happy. Oh, you are at least maintaining that visibility. If it was package above, public here, no problem. Okay, now our code will compile. Oh, no, there is some more error. Oh, there is a flower bracket missing. Missing return. Oh, sorry. Oh, sorry. getMessage should not say system.out.println. It should return that string. I'm sorry. It should not print anything. It should return that string. Whoever is calling getMessage must print it. Okay. We made that error. It's a return type, no? Okay. Whatever the string, it has to return it, the message string. Okay. So now we'll try and run it. Yeah. So as you can see, as we described, so it happened. The program compiled and ran. No problem. Yes, no. Why did the program compile? Because the exception was a runtime exception. That is why it compiled, correct? And it ran. You see what is the output? First issue succeeded, obviously, because at that time the inventory or quantity on hand became only 125. When we tried to do the second issue of another 75, the quantity on hand dropped to 50, okay, and it gave that error. You will see that a message also coming in the exception. This is coming because the program is bombing out. If you see, can you scroll to the right? Yeah, the quantity on hand now is, it's showing 5. If you scroll a little more, yeah, so it's showing 50, okay. This is the new quantity on hand, which is below the reorder point. That's why we have an exception. Okay, this is if the exception is a runtime exception, okay. This is a runtime exception because I made it derived from runtime exception class. Now, how can I make it a checked exception? Right now it's unchecked. How can I make it a checked exception? Yes, what change do I have to do? What do you think? What do I do? I'm sorry? Remove the parent class. No. And say what? What change should I do? I want it to now become a checked exception. I have not explained, I have not told you what to do, but it's very easy to guess. So I'm asking you to guess, what should I do to that exception so that it becomes a checked exception, and my program itself doesn't compile saying I have not either reported or handled this exception, because I am not handling the exception. So what should I do? Good. So instead of saying class shortage exception extends runtime exception, that is what made it a runtime exception. I shouldn't say that. What should I say? Class shortage exception extends exception, just exception. Because if it comes from exception hierarchy and does not come under runtime exception hierarchy, it automatically becomes a checked exception. Just remove that runtime exception and say exception. Okay, now it's a checked exception. Now what will happen? Now my code only won't compile, because now there is a possibility in the issue method. I am calling issue method. In the issue method there is a possibility of a shortage exception, which is a checked exception. Now you'll say, why is it a checked exception? Because I derived it from exception class. That's why it's a checked exception. So it's a checked exception, and okay. So because it's a checked exception, now you'll see when I compile the program or try to compile the program, we'll compile the program. Now see, there itself it is giving an error saying unreported exception, unreported or uncaught. So any checked exception must be either caught or reported. I have not done both, because right now my exception is a checked exception. So I have to do now two things for our code to work. Okay. So first thing I should do is, I should go to the point where the exception is raised. Which method is raising the exception? Issue material. Okay. So let's go to issue material. Okay. Now, we should not catch the exception. We should only throw, but we have to declare. See, the issue material will never catch the exception. It will propagate to main, and main will catch it, because the calling program which is doing this must catch it. Issue material must not catch it. The calling program must catch it. So, but it has to be reported in issue material. So what will I say? Issue material throws shortage exception. Throws shortage exception. Okay. Now issue material is fine. So it throws a shortage exception. It will create a, it is telling the compiler, Mr. Compiler, I am now going to throw, I may throw an exception called shortage exception. So he says, good. Compiler tells issue material, you are a beautiful guy. Whatever checked exception you are saying, you will throw it. You are reporting it. You will not catch it. But now the Java compiler looks at main. Let's go to main. It looks at main and says, I see that statement issue material. That is a method which potentially throws an exception. But Mr. Main, you have not made any provision either to recognize this exception or to catch this exception. I will not allow you to compile now. Issue material, no problem. He is saying, he is reporting an exception. So he has taken cognizance of that exception. He knows, he is telling us that he will throw a shortage exception. But what about you, Mr. Main? What about you? You are not telling us anything. You are not even seeing, or you are not telling the compiler that there may be a shortage exception in my code. And that the compiler says, because it's a checked exception, I will not allow. You either report it, let main report it, I am happy, or, which is the right approach now, catch it and give a message. Yes? So the right approach for main is to catch it and give a proper message to the user. So we will now write a try block. Okay. So we are writing a try block. We'll push all this code into the try block. And we'll write a nice catch block, where we'll catch what exception? Shortage exception, SE. And on that SC I will say, because I have a get message, remember now? So I have a get message, so I will say system.out.println sc.get message. Remember, get string, which will be now printed. So see that now. I am going to get the exception from issue material, not the first issue material but the second issue material. But issue material is good now because it is declaring that it can throw an exception. I am getting ready to handle that exception. I have put a catch block, and in that catch block, whatever message comes along with the exception from its own get message method, I am faithfully reporting that exception. Okay, I am giving the message related to that exception. So I am saying sc.get message. Now let's run this code and you will realize the difference. Okay, first of all, it will compile, it will run, it will get that exception, and it will show the message associated with that exception. Okay. Now you see, first issue succeeded, and at the second issue, exception came, the exception was caught, and we got a message related to that exception. The message is, the quantity on hand has dropped below the reorder point. The QOH is now 50 after the second. So the second issue didn't happen, correct? Why did the second issue not happen? There was no enough quantity to issue the second time. First time it worked. So you see, first issue succeeded, second issue didn't succeed. Instead we got an exception which we caught. So this is called user defined exception. So what did we do? We wrote code. We understood why we need user defined exceptions, because these kind of exceptions you have to create. And a Java programmer spends at least 10-15% of his time visualizing the application, realizing in this application what exceptions have to be created, creating those exception classes, and then writing the rest of the class. So it's very important for any Java class designer to look at his methods, understand these methods, what exceptions they may need, then decide whether they should be runtime exceptions or checked exceptions, then create those exceptions, decide when you have to throw them. If they are checked exceptions, then the method which is throwing them has to report it by saying throws. Then in the main code, because it's a checked exception, code won't compile. You have to put a try-catch block or a reporting block. So you have to manage it carefully. Okay. Yes? No? This is all that is for exception management. So we started 3 sessions earlier. Okay. We first discussed why there are exceptions in code. We talked about optimistic code, pessimistic code. We said, I don't want to write either. I want a try block where all the main code is there. I want a catch block where I do all error handling. I want it separate. That's how we started thinking about exceptions. Then we realized that there are in Java a lot of predefined exceptions. Then we discussed what are checked, what are unchecked. Then we discussed the need for finally and how finally can be called, why should finally be there for cleanup of code. Then we discussed there is an escape from finally. Right? Then we talked about exception propagation, how exceptions propagate up. Then we discussed how to handle that propagation. Should you handle it locally or should you handle it globally at one place? We discussed how to make that happen globally, locally. What is the whole story of propagation and why propagation can cause problems or advantages. And then we discussed the keyword throws, throw, what do you do with checked, what do you do with unchecked, and today we saw what is a user-defined exception. This is the exception theory. This is first of the big ones. As I said, there are 5 big topics in Java. This is the first big one. The second big one is even tougher because it's all thread management. You need to know a little bit about OS and for your syllabus, we are not just doing the old thread management, which is anyway nobody does now, but the new thread management, which is called the non-blocking I/O or the NIO or concurrent threads, which have changed the threads completely. So we are doing that, which we'll do next. Then we'll go on to generics, then streams, and so on. So all the tough topics are now beginning. Okay. So this is the first of them. So it is tricky, but very powerful. And to understand streams, you need to be very good at lambda programming and comparator, which I'll do before. So the heavy stuff will come. It's heavy, I'll admit. But if you don't understand it, you don't understand object orientation. And please, the central ideas are the same, whether you do Java, whether you do Python, whether you do C++, all these ideas will keep coming in one way or other because they are contemporary programmers' tools. You cannot escape them. Today, programmers have to use these tools and they have to become comfortable with using it. It's not just learning it as a subject. You have to use these tools. Okay. Now we have a big quiz of 25 questions, but before that there are a couple of small concepts which we always leave off, which I'll do, very simple concept, and then we will go into that. Okay, we'll do the quiz. But just before that, we will do this. I think I will have to explain it here, so hopefully you will understand. Okay, this is some general ideas about exceptions, which you should know, which are not normally covered in a university kind of course, but in a professional Java programming exercise, it has to be done. So let's say you have a class base and let's say it has a method M1 throws void M1, throws some exception and we have the body for M1. So please understand what I have created. It's simple. I have created a class base. That class base has a method M1. M1 throws an exception, obviously a checked exception. Throws exception, I have this. Then I have a class derived. Again, it is overriding the method M1. Now, and it has a body like this. Okay. Now, this will compile. The base class is throwing an exception. The base class method is throwing an exception. Derived class method is not throwing an exception. This is okay. This Java allows because it says, looking from the base class, if I am using this reference, I have made provisions for exception handling. If the derived class doesn't give an exception, I have not done harm. I have not done damage because I am using this reference. If I am using this reference, that is base class reference, and so I am saying, let's say, base B is equal to new something. I am saying B dot M1, I am calling B dot M1. While calling B dot M1, I would have either written a try-catch block or I would have reported. Are you understanding? Because this is a checked exception which is getting thrown here. Yeah. Now, an exception which is thrown here. This will work. So even if B points to new derived, no damage done, because this is anticipating an exception, it doesn't come because the derived class method doesn't throw an exception, which is okay. I am over cautious. I am in the base class, have that exception. Derived class I am not throwing. So when I use a base class reference, I will be prepared for an exception which may not come from the derived class. No problem. No danger. Okay? But if this is not there, instead I have throws exception, then Java compiler says no. this override I will not allow. Why? Because the base class method, when it is invoked using a base class reference which may point to a derived class object, at that point I have not, because this doesn't throw any exception. So when I wrote this code, I did not write a try catch or anything because I was not expecting an exception. If you look at this M1, this was not throwing an exception. But the derived class now started throwing an exception. That I will not accept. Base class throws exception, derived class doesn't throw exception, fine. I made anyway provision to handle that exception, derived class is not giving. But the vice versa, the base class method is not throwing an exception. Its overriding method in the derived class is throwing an exception, then Java compiler says this is not permitted. I will not allow this to happen. Okay? Now, this will not be allowed. There is a reason. Because the guy who is writing this class and using this functionality, he is seeing only B. When he is seeing B, he is not preparing for handling this exception because his M1 does not have any exceptions. He is not preparing. Whereas actually when it is getting called because of this new derived at runtime, an exception is expected to come and I have not handled it. Now again, this will not be allowed. However, if it says runtime exception, no problem because I have to make no provisions. Runtime exception anyway I have to make provision, I will allow. This is allowed. If I had said throws exception, not allowed. Throws runtime exception, allowed. Because anyway I don't have to make any provision, it's a runtime exception. Okay? Okay. Now, some of you, I'm sure now, most of you have not understood this. Okay? I'll make one more attempt to get through you. It's like saying, when I design base classes and derived classes, when in Java you have to be always aware, please understand this, or even if you not understand it, at least think about it. Always we should be prepared that because of polymorphism, a base class reference can point to derived class object. So, if the method in the derived class is expecting something more to be done, and the method in the base class doesn't expect that to be done, then we have an issue. Because when I write code, I will write, because I am using a base class reference, I will write it with respect to the base class. I will not write it with respect to what it is pointing to at runtime. So if the base class code is not prepared to give an exception, derived object gives an exception, then I have a soup, other than runtime exception. Okay? Then I have a soup. So Java compiler watches that and says, I will not allow this to happen. Okay? Because this is like saying, how will you allow? Okay? So let's first play with this little bit and understand this. This is very important. Okay, watch this. We'll create an example for this. Watch it. Okay, we are doing it in day 14, lab 2. Okay, we'll create a class base. Okay, class base in which I will create a method M1, void M1. Okay, just leave it like that. Now I will create a class derived. Void M1, and it will say throws exception. This is the situation I was trying to simulate. Base class method is overridden by the derived class method M1. M1 derived class is throwing an exception, not in the base class. Now, forget what happens afterwards. Let's see let's write a small main, extends base, correct. Let's write a small main. Right now, let's not do anything in main, okay. Let's just see whether this compiles without doing anything, okay. Okay, just very simple code, M1, overriding method, derived class method is having saying it will throw an exception, it's not throwing any exception, okay. If you want, we can throw, it's just reporting blindly. Okay, now try to compile this code. Okay, now you see the error. Watch it carefully. Okay, let's read the error. M1 in derived cannot override M1 in base. He's saying I will not allow this overriding. Why? Because overridden method does not throw, overridden means the method in the base class, that is the overridden method. The method in the derived class is called overriding method. The overridden method, that is the base class method, is not throwing an exception, and in the derived class we are throwing an exception. So he's saying I will not allow it. First ask your base class to throw an exception, then I'll allow you to throw an exception, because it's a checked exception. Because otherwise the base class method will never be prepared for this exception, because it's happening suddenly in the derived class. Derived class cannot add a new exception which is not anticipated in the base class. Okay. So this is a very important problem. Okay, this is an error. Now is everybody clear why that error is coming? Yes? No? Okay, now I'll just try and play with, instead of the derived class saying checked exception, which is exception, I'll say throws runtime exception. Let's see whether the behavior changes. Okay, now there is no problem. Why? Because Java is very forgiving with runtime exception. Runtime, let it be. Checked exception, derived class cannot throw more than base class. Derived class cannot throw an exception when the base class is not throwing the exception. Vice versa, no problem. Okay, let's do the vice versa. So we'll remove the runtime exception, no problem at all. Okay, throws exception. Is this okay? No, yes. Derived class is subdued. Okay, it's not throwing exception. Base class is having more problem, and derived class is not doing it. So no problem. Anybody who is writing using base class will anyway make provision. Okay. Okay. Now let's try and compile. Okay. Again, no problem. Code compile. We are not talking about running. We are just talking about compiling. Yes. No. Okay. Now, this is one rule, keep it in mind. Derived class exception cannot throw an exception other than runtime exception if the base class is not throwing exception. So, now I'll change it a little. I'll say the base class throws IO exception. Both are checked exceptions in a moment. Okay? IO exception. And derived class throws exception. Now, what do you think? Let's see how many of you can give me an answer. Will it work? Both are throwing exceptions, but base class is throwing a derived kind of exception, which is at a higher level. Exception or IO exception? Exception. Exception is higher level, IO exception is derived from exception. Acha. Now, again, Java says no. It says the derived class can show more specialized exceptions, but not more generalized exceptions. Again, I am repeating, please understand, these are deep concepts. Again, I am saying, derived class method can throw specialized exceptions but not generalized exceptions of the base class exception. So, what is happening now? Who is more generalized? Who is general exception here? Exception or IO exception? Exception. That is the more general one. The more general one is in the derived class and the more specialized one is in the base class. Not allowed. Ulta, allowed. That is, base class can throw more general exception and derived class method can throw specialized exception. It's actually, if you realize, a corollary of the earlier rule, of the previous rule. Okay, now this won't compile. You watch. Okay. Yeah, it is saying same similar error, throws IO exception. No, this error is something else. We are doing java.io.star1. This is not related to exception. We didn't import java.io.star. That is something else. We'll watch now. Okay, watch now. Now you will get the appropriate error. Go up. So, overridden method does not throw exception. Overridden means base class method. Derived class method is throwing exception. Always remember, derived class method are derived. So, they also should throw specialized exceptions, not generalized. Generalized should go at the top. Here, IO exception is at the top, exception is below. It should follow the class hierarchy only. Or same is fine. So now this won't compile. And if I reverse it, that the base class can throw exception, which is the base class exception, and derived class can throw derived class exception, that is the method, overriding method. This Java says, I have no problem, because anyway, there is a base class there is a derived class here. So if you run it, okay, no problem, Java will run. Have you understood anything? No, yes. So what is the moral of the story? I am going to say this in a nutshell, what you just saw. Base class method does not throw an exception. Derived class method throws an exception. This is an overriding. Then, if that exception is a runtime exception, no problem. But if it is anything which is not runtime exception, problem. It will not allow derived class exception to throw more checked exception than the base class. First rule. Second rule, the exception hierarchy should be obeyed. That is, the base class has to throw, base class method has to throw the base class exception. Derived class method has to throw the derived exceptions. Reverse cannot be applied, which we tried to do just now. Okay. Second rule. Okay. Now, maybe at this stage, this is some extra rules that you should know. This is very common in all tests which check Java competency. Okay. And most of the time you don't know what is going on. So please be clear that this is what sometimes is a question. Okay, there is one more question, which is related, and I think I'll cover it because it's there in today's quiz, which we will do soon. So I want you to be not having out of syllabus kind of idea when you look at the quiz. There is one more change which came not in Java 8 but in Java 7. Okay. For the try-catch, because these things have been changing over time. These are so fundamental to programmers that the whole Java community wants these things to change frequently. So you see many things keep happening, and people who really do a lot of coding or people who are deep into coding, they watch a lot of these things to understand why they are happening. And my conclusion normally is what the industry also concludes, that right, because he has not learned a language well. If you know Python well, you will know Java well. If you know Java well, you will learn Python well. Very simple truth. So when somebody says I am good in one, that means you are good in none. You have not absorbed the core of the language. Python is also doing lambda programming. Python is also doing streams. Python is also improving its exception handling, which it was weak. Python is also doing a multi-threaded model in a different way, which is also what it was weak. Everybody is doing it. Only thing is, the superficial programmer thinks, oh, this is different, that is different. That is very superficial. When you are understanding a language at its core and at its depth, they are not very different. They are all the same. Remember, I talked about try, and then I talked about catch, and then I talked about finally. We said finally is an excellent place if you open a connection here. You need to release it somewhere. So rather than releasing it here or in any of these catch blocks, you release it in the finally. So release the connection or close the connection. You do it here. So you have to write a try block and a finally block. Now, in version 7, they introduced a slightly different version of try block, which before it starts this bracket has a piece of code. Okay. Now look at this. This is a slightly varied form of try, which is called try with resources. This was introduced in 7, Java 7. It is written like this, try. Only thing is, look at this syntax, look at this syntax. There is a parenthesis here and open bracket, open flower bracket and close flower bracket. Now here, you can open all resources, open all the needed resources. Okay. And these resources, you need not close. This is called try with release. This is a special kind of try, or try with resources, sorry. This is called try with resources. This is a form of try which was introduced about 7-8 years ago. And what it does is, whatever you open here automatically gets released. You don't have to worry about release. And this block does not need a catch block or does not need a finally block also, because its purpose, if you want you can add, but it's not mandatory. Especially finally is not necessary, because what is finally's job? Release the resources. So this automatically it is going to do here. But the resources it releases have to implement an auto-closable interface. Auto-closable means automatically closable. That's a special kind of interface. If you are interested, you can do a bit of reading, research and all that. So all these objects or classes which are used here have to implement an auto-closable interface. If they do that, then you can use a try without catch or without finally, especially finally, which purpose will be served here itself, but only with auto-closable resources. If you don't have an auto-closable resource, then you have to write finally. Okay? So this is tested in these coding tests, coding what do you call it? Quizzes. So I am introducing it. This is a Java 7 feature. Okay? A lot of features have come in new, but this is a Java 7 feature which has been introduced. Did you understand this feature at least? No, yes? Do you understand its purpose? Because you don't need finally. New feature. Okay. But that resource which can be closed has to implement auto-closable interface. If it doesn't, then you have to write finally to close the resource. Most of these resources, files, buffers, they implement it. So you don't have to close it. Okay. Anyway, we'll discuss more about it as we go deeper in Java. Maybe this semester, maybe when we start finishing school, whatever. So, okay. So we are done with, this is the theory of Java, Java exceptions. Okay. That's it. This is all that is in exceptions. You can't have more than that. So I think we are at 11:15, right? Okay, let's take half an hour to do the quiz and then we'll discuss the answers quickly in about 15-20 minutes. It will take half an hour to do the quiz. Yes, no? Take your time. Don't do it on the machine except that. Think, do it. We have covered all the theory for those questions. There are 25 of those. It's for your own personal understanding how far you have understood Java. That's all. That's the only thing we are trying to get. Take your time, see how much you can answer. Understand the question. Okay, please save. Please save, we are closing. Please submit. We'll come back. Let's just go through the quiz once, quickly. No, I'm not going to spend too much time. Could you answer something? No. Okay. I hope it is better than yesterday. Okay, which of the following statements is true about Java's finally block? The finally block is only executed if an exception is thrown. No. The finally block is only executed if the exception is thrown in the catch block. No. Finally is only executed if an exception is not thrown in. No. Is executed regardless of whether an exception is thrown in the try or catch block. I think that everyone knows. Okay. D. Next. Okay. What will be the output of the below snippet of code? So you have a class ABC extends exception, and you have a main method which is instantiating that exception and throwing it, and you are catching that exception, and also there is a finally block. So what will happen? So exception is thrown, or will there be a compilation error? There is no compilation error, no? There is test, main, throwing an exception which is derived from exception class, and so what is the output? Caught the ABC exception and finally, correct? Correct or not? Simple, no? Okay. So caught the ABC exception, finally caught. Finally will never be escape. And you are catching the exception which you are throwing. You are throwing the exception, you are catching the exception. Nothing wrong about it. Okay. How do you throw an exception? Just say new, and just like we did in user defined exception. Okay, next. So, now there is a parent exception which derives from exception class. This is a question related to what we just talked about last. So there is a parent exception class and there is a child exception. Okay, so hierarchy should be obeyed. Then there is this is different. Okay. So child exception extends from parent. Then we have main. We always start looking at main. Main, throw new child exception. What is the error here? It's an old error. Look at the catch blocks. What is happening? This is a common trap, no, of question. Good. Are you seeing the problem? The catch blocks, what is the rule? The generalized catch block should be afterwards. The specialized catch block should be before, always. Specialized means derived. Generalized means base class. Specialized should precede generalized. I have talked so many times. Generalized should be later. Because if generalized is earlier, only generalized will execute. It will never go to specialized. How will it run? So it will give a compilation error. That is what has happened here. The base class exception, that is generalized, is above and the specialized is below. So it will give an error right there. So caught, no. Compile error because derived, no. Compile error because base class exception. That D is the answer. Base class exception is caught before derived class exception. Not allowed. Specialized first, generalized later. Violating that rule. So the answer is D. Next. What is the output? So again we start from main always. So where is main? Main. So what method is called? M1 is called. Okay, so let's go to M1. What is M1 doing? There is a string S instance variable which will start with P, and then M1 is called. So what will M1 do? M1 will do PQ. Now it will become PQ. Now M2 will be called. There will not be any exception here, so it will not go to R. So now it is PQ. It goes to M2. M2 is throwing some exception, but let's see what happens. M2 is now PQS, and M3 is called. M3, yeah. M3 is throwing an exception. So once so M3 is coming out, M3 is not doing anything except throwing an exception. So we are back in M2. So far we have got PQS, and now on M3 we have an exception which is thrown. That exception will be caught, but again the catch block is throwing another exception which is not caught. So finally will anyway execute. What will finally do? Finally will do PQST. Finally is doing T, and because finally block will be executed, but still there is a pending exception which was raised on line 18, that concatenation of U will not happen, and then print will be called. So what is the string so far? PQST, and is there finally is printing something more? PQST, R will it come? Or U will come? Is there a, no, U will not come, but how about R? M2, M2 will come out with an exception, sorry, M2 will come out with an exception. This is better. So M2 will come out with an exception because M3 is throwing an exception. See, M3 is throwing an exception which goes to catch block. Catch throws an exception, that is caught. So R will come. So PQ S T and R. Am I right? No, please understand what is happening. You are getting P, then you are getting Q. Now M2 is getting called, so you should enter M2. M2 throws an exception, fine. That is just a reporting. What is happening in M2? S is getting concatenated. So what do we have so far? PQS. Yes, no. We have PQS so far. Now M3 gets called. What does M3 do? Again throws an exception. Now that exception is caught on line 17. Okay. But another exception is raised. So M3 is coming out with an exception. And what is the string so far? When it comes out from M2, that finally will be executed. So PQST will happen. But that line 23 will not execute because there is a pending exception. So far I have PQST, and then it will come to M2, that is M1, where M2 is called. So it was coming to M1, that is line 6. Line 6 it is coming with an exception, that will be caught, and now it will become PQSTR. Everybody understood or no? Everybody clear? PQSTR. Okay, so that is the answer. Next. Okay, so this is nested try block, fine. So M1, always think from main. Main is creating the demo object, calling M1. So let's see what M1 does. Val is 0. Val plus plus will make val 1. Again try block. You can have any number of nestings. 1 plus 1, 2. Third try block, line 9. 3. Now exception. Exception, it will go to the exception handler, line 13. 4. Now there will again be an exception. Again that exception block of the outer try block will catch. So 5. Now there is no exception waiting, only exception thrown, caught. So line 22 will not run because there is no exception now. Whatever were thrown, caught. Val increase. So it became 5. Now answer is 5. Did you understand? No. You just have to think try block, increases, goes deeper, okay, and every time it increases val, and there is a catch. Okay. So which catch blocks will be encountered? 2 times. So val, only 2 exceptions are there, so 2 catch blocks. Third catch block will not be encountered, so the last val will not be executed. Okay, on line 22, it will not go there out, because whatever exceptions are there, they will be caught. Only if there is a pending exception, it will go there. Next. Okay. So again we start from main and we want to see the output. Int I equal to 1, I less than or equal to 5, I plus plus. So first it will print 1. Then it will print A. Is I equal to 2? No. I is not equal to 2. So far we have got 1A. Then that finally will not, finally will also run, because try block is executed and I is 1. Remember, I is just 1. So we have so far 1A, B, finally is over. Then because there is no exception, try finally is over, and I don't know, C will be executed, and because C is just after the for loop, inside the for loop. C is inside the for loop, no? So I have so far 1 A, B, C. Okay, 1 A, B, C. 1 because of system.out.print I, 1. Then after that A, I equal to 2 is wrong. Finally of that try block will be executed. So B, finally can't be escaped. So B is there. So 1 A, B. Now outside the finally, but in the try block, there is C. So 1 A, B, C. Now the try block has finished on that line, and then but the while is still going on. While is not finished, no? Only try is finished. Only try is finished. So D will also come, no? So 1 A, B, C, D. Sorry, for. Where is for ending? Is it ending there or? So it is 1 A, B, C. For ends there. Okay. So I'll have 1 A, B, C. Are we clear? I'll not get D. D is outside for. We are not exited for. So now we will get 1 A, B, C. Then again I will become 2. So when I becomes 2, I will get A again. So 1 A, B, C, 2. So 1 A, B, C, 2. Then try block A again. So I have 1 A, B, C, 2 A. 2A, I equal to 2, return. So it will return. Now the question which they want to quiz you on is, or test you on, will finally execute or not? Yes, no? Yes. Only when there is exit. Finally can be escaped. Otherwise there is no escape from finally. So 2, you have that 1 A, B, C, 2 A so far. Okay. Then what will happen? It will return. Oh, that's it. That's it. It will return with finally B. Yeah. So whatever. 1 A, B, C, 2 A, B. Am I right? Does everybody get it? It's an easy question, not difficult. You just have to know what happened. Only thing to remember is finally will be executed if you do a return. No escape from finally except exit. Okay. So the answer is 1 A, B, C, 2 A, B. Correct. That's the answer. Next. You always start looking at main. Okay. So main we have M1. M1 is getting called. This is similar to what we did. Okay. M1 is getting called. M1 prints A and returns 10. So that 10 is printed. But there is a finally block also. So we can't escape finally. So far what we have got A, returning is 10, but before returning it will have to go to finally. So A, B, then if true is always true. So we'll have A, B, return 20. So it's returning from there only. So if true, return 20. So it returns there. So 20. So A, B, 20 is returned. Is it A, B 10 or A, B 20? No. What's the answer? A, B 10 or A, B 20? 20. See, return came finally went because of the return. So whatever finally says will override. So I think the answer should be from finally. So it should be A, B, 20. True is always true. Okay. Yeah. Correct? Traditional try means old try. I told you there are two tries now. One try is old try, traditional try. What is the other try? That try with resources. Remember I just told you about Java 7. Okay. Achha, all these questions and interviews today assume Java 8. So whatever is there in Java 7, you are assumed to know. Except we have now changed syllabus also. In the new syllabus we have all Java 8 also. Old syllabus only Java 5, no use. The industry standard of Java is 8. Okay, so you should know everything that happens in 8 also. So 7 is obviously there. So let's go one by one. Traditional try statement without a catch block requires a finally block. True or false? A try block, traditional try means old try, not Java 7. Try block doesn't have a catch block. Will it need finally? Yes. Otherwise try block will be hanging in air. Try will need either catch finally or both. The old try, that is called traditional try. A traditional try without a finally block requires a catch block. Yes. If it doesn't have finally, it requires catch. A traditional try with only one statement can omit. No, it cannot. It always has to be in bracket. Even if one statement is there, it has to be in that try block. So far, A and B are correct? Then D, without a catch, okay, D, a try with resources, that is a try block. A try with resources without a catch block requires a finally block? No. Both are optional. So D is not needed. A try block with resources block, with a try with resources statement without a finally block requires a catch block? No, no requirement. A try with resources statement with only one statement can omit the flower brackets. Can it omit the flower bracket or not? Okay. No, I don't think it can. So we will ignore it. Good. No, this I didn't know. It's a choice. Okay. Because you can't omit the flower bracket. You need the flower bracket for try block. Okay. I think we'll stop here.